Hello everyone, I am Karan Mashru. Welcome to this video. In this video, we are going to discuss solution of the problem of the day, that is Stickler thief. First of all, let us start by understanding the question. What does question say? It says that Stickler the thief wants to loot money from a society having n houses in a single line. He is a weird person and follows a certain rule when looting the houses. So basically there is a society in which there are n houses in a single line. Okay, so suppose these are the houses and the thief wants to make a loot among these houses, but he follows a certain rule. What is the rule? According to the rule, he will never loot two consecutive houses. At the same time, he wants to maximize the amount of he loots. So basically the thief wants to loot among all the n houses of the society, but the rule is that no two consecutive houses should be looted. No two or more consecutive houses should be looted. So he will not loot these two houses together because these two are consecutive. He will not loot these three houses together because these are consecutive. So what would be the loot type? So suppose he loots this house, then he will loot this house and he will loot this house. Suppose this is the possible combination. Why? Because these are not consecutive houses. There are houses in between as well. Okay. And he wants to follow this rule, and at the same time he wants to maximize the amount which he can loot. Okay. The thief knows which house has what amount of money but is unable to come up with an optimal looting strategy. He asks for your help to find the maximum money he can get if he strictly follows the rules. Ith house has AI amount of money present in it. So now there are with the help of an array A, we are told what amount of money is present in which house, and we need to return what is the maximum amount of money the thief can loot among these n houses, keeping the rule in mind. That is, no two consecutive houses will be looted together. Okay. So if we look at the example, suppose n equals to 5 and the array has 6, 5, 5, 7, 4, which represents the amount of money in each house, then the maximum which he can loot is 15. How? He can take 6, he can take 5 and he can take 4, the middle 5. Okay. So these are not consecutive, and 6 plus 5 is 11 and plus 4 is 15, and that is how we will get the maximum amount of loot. If we look at the second example, in this he can loot the middle house which has the value 5 and he will get maximum amount of money. Okay. Complete the function find max sum, which takes an array which represents the amount of money in each house, and n, that is the number of houses as input, and which returns the maximum money he can get following the rules. Expected time complexity is big of n and expected space complexity is big of n, and the constraints are given here. So now if we think about solving this problem, then basically we need to tell the maximum amount of money which the thief can loot from the n houses, such that he will not loot any two consecutive houses. Okay, and the amount of money in each house is given. Okay. Now first of all, I have taken this example because there is a misconception which can occur. Okay. So in order to resolve that, I have taken this. What is the misconception? The first thing which comes to mind is that, okay, we cannot take loot consecutive houses, so let us try and take alternate houses in which we can loot maximum number of houses. So suppose there are 6 houses, then loot this, do not loot this, loot this, do not loot this, consider this, do not consider this. This is the one possibility. Other possibilities: do not consider this, do not consider this, consider this, do not consider this, consider this. And out of these two cases, the case which returns maximum amount of money is our answer. But this approach is wrong. Okay. Here definitely you will be able to loot the maximum number of houses, but it does not guarantee the maximum amount of money. If we look at this example, here we have 10, we have 2, we have 3, we have 15, and we have 1. Okay. So now consider 10, do not consider this, do not consider this, and consider this. What would be the total amount of money which you will get? 10 plus 3 is 13 plus 1 is 14. But what is the maximum amount of money you can get? Consider 10 and consider 15. Since you have considered 10, you cannot consider 2. Since you have considered 15, you cannot consider 3 and 1. And the total amount of money which you can get is 10 plus 15, which is nothing but 25. So this misconception may occur to many people that, okay, take alternative houses and out of these two cases take the maximum one, but that does not guarantee the maximum amount of money, right? Now here, so basically what we need is that out of all the subsequences of the array possible in which no two consecutive elements are considered, so out of all such subsequences, the subsequence which gives us the maximum amount of money is our answer, right? Because we cannot consider all the subsequences. We need to consider the subsequences in which no two consecutive elements are considered. Okay, and out of all such subsequences, the one which gives the maximum sum is our answer. Now how can we get all these subsequences? We can apply recursion, right? So suppose starting from the end, I am suppose there are n elements in the array, so there are n houses, okay, and I want to generate all the different subsequences or the sum. Okay, now how can I get that? So basically for each element I'll decide whether to take it or not to take it, and I'll also keep the rule in mind that no two consecutive elements will be taken. So from end I am starting that whether to consider the last element or not to consider the last element. So first of all, I'll call the function max loot recursive function, and the last index n minus 1 would be passed. So this will basically return me the maximum loot which is possible for the elements from 0 index to n minus 1 index. Now, so in this I'll either consider the last element, I'll either loot the last house which is at index n minus 1, or I'll not loot it. So in case I loot it, so my answer would be max loot among the first n minus 2 houses from 0 index to n minus 2 index, plus the amount of money which I can get from the last house. Or if I do not consider to loot the last house, then it would be maximum loot possible out of 0 index till n minus 2 index. That is what this function will return me, and my answer to this recursion function would be max of these two. So either consider this element and plus the maximum loot among the first n minus 2 elements, or do not consider that element, right? Now when I consider that element, further for the element at index n minus 2, I do not have a choice. I will not consider it because I cannot consider two consecutive elements. Okay, so I cannot take the case where I consider the element at index n minus 2. So I'll not consider it. So it will basically be equal to max loot possible out of the houses from index 0 to index n minus 3 plus array of n minus 1, because I considered that in the first step. Here I have not considered anything till yet. So here I have two choices, either to consider the house at index n minus 2 or not to consider it. If I consider it, my answer would be max loot up till index n minus 3 plus array of n minus 2, and if I do not consider it, it would be max loot up till index n minus 3. Okay, now if I go further, here if I see, now this is max loot among the first n minus 3 elements. Now I can consider the house at n minus 3 index, or I do not consider it, because n minus 1 and n minus 3 are not consecutive. So again I have two choices. So this will be equal to max loot up till index n minus 4 plus array of n minus 1 plus array of n minus 3. I decided to loot the house at index n minus 3, or I do not decide. So it would be equal to max loot among the houses till index n minus 4 plus array of n minus 1, and so on, and this will also go on, right, until this becomes minus 1, because starting with index n minus 1 I'll go till index 0, and when it becomes minus 1 we will finish the recursion and go back. And for each step the answer to this would be max of this or this. So either we consider that element or we do not consider it. For this, answer would be max of this or this, but this is not possible, because if I have considered the house at index n minus 1, I cannot consider the house at index n minus 2. So this will be equal to this. The value of this would be max of this and this. The value of this would be max of this and this. Either consider the house at index n minus 2 or do not consider it. So ultimately this recursion call will be done, and the max of all the elements, like max of all the possible values, will go and return in the recursion function, right? What would be the time complexity? See, in general, if we think about the time complexity, it would be big O of 2 ki power n, because we are trying to generate all the subsequences, but it would be not this much, it would be quite less. Why? Because we are not considering such a recursion where consecutive elements are taken, but still it would be like we can give an upper bound of 2 ki power n, it would be exponential. Now we want to convert this exponential time complexity into polynomial. Can we think of dynamic programming? For that we need overlapping subproblems property. Do we have overlapping subproblems property? What does that say? It says that same subproblems are solved multiple times. Yes, we have that max loot up till index n minus 3, max loot up till index n minus 3, max loot up till index n minus 2, max loot up till index n minus 4. This is the same problem which is recursively called, right? And do we have optimal substructure property? What does it say? That the optimal solutions of smaller problem are used to derive the solutions of the bigger problem. Yes, these are the optimal. Here I'll get the optimal solution for this max loot up till index n minus 4. Here also I'll get this, and I'll use both of them and I'll find the solution for this. I am using the optimal solution of sub problems, and whichever is the maximum one, I am returning it to the bigger problem. So I also have the optimal substructure property, and I also have the overlapping sub problems property, and I want to convert the time complexity from exponential to polynomial. So I can think of it in terms of dynamic programming, right? So now let us think of the tabulation approach of the dynamic programming, in which we will fill up a table. Now what would be the state or the parameters that are considered while filling up the table? What would be the table type? If we look at here, our recursion function has only one thing, index. So basically I want only 1D array. So I want an array dp of n, where dp of I will denote the maximum loot which is possible up till index I, considering the rule as well as considering the first I elements, what is the maximum loot possible. So we will fill up this table dp of n, and finally we will return dp of n minus 1, which will denote the maximum loot which is possible, keeping the rules in mind, and considering the first n houses from 0 index to n minus 1 index. So now we need to fill this. So in tabulation, what we do? First we fill the base cases, and then we make a for loop and fill the whole table. So what is the base case? If we consider only the first house, what is the maximum loot possible? The maximum loot possible is to loot the house at 0 index, because if there is only one house, we do not need to think about consecutive houses, right? So first of all, dp of 0 would be equal to array of 0. That is the maximum loot possible if we have only one house, if equal to this. And for index 1, what is dp of 1? It is the maximum loot possible considering the houses from index 0 to index 1. So what would be that equal to? Either the house at 0 index or the house at 1 index, because we can't take both of them, those are consecutive. So dp of 1, which basically denotes the maximum loot possible considering the houses from 0 index to 1 index, is maximum of dp of 0, which is nothing but array of 0, and array of 1, which is nothing but the money in house number 1. So either we loot the house number 0 or we loot the house number 1, right? Now from index 2 to index n minus 1, we will fill it using the table, using the for loop. So for I equals to 2 to n minus 1, dp of I is equals to, so what would be dp of I? See, when we are calculating dp of I, dp up till I minus 1 is already calculated. So dp of I, in this we think whether to take the ith house or not. Here also we were doing the same thing, either take the nth minus 1 house or do not consider it. So dp of I can say it would be maximum of, either I decide to loot the ith house, so it would be array of I plus dp of I minus 2. Because if I decide to loot the ith house, I cannot take I minus 1th house. And in dp of I minus 1, which denotes the maximum loot possible from index 0 to index I minus 1, the ith minus 1th house may be considered. So if I consider looting the ith house, then it would be array of I plus dp of I minus 2. dp of I minus 2 is maximum loot possible from index 0 to index I minus 2. So we are not considering consecutive houses. And if I do not consider to loot the ith house, it would be dp of I minus 1. That is the maximum loot possible from index 0 to index I minus 1. So dp of I, that is the maximum loot possible from 0 index to ith index, is either equal to maximum loot possible from 0th index to I minus 1th index, or the maximum loot possible from 0th index to I minus 2 index plus the ith house. Okay, so no two consecutive houses are considered anywhere. And finally we will return dp of n minus 1, which will denote the maximum loot possible from index 0 to index n minus 1. Now let's look at its actual code. So if we look at the actual code, so what I have done here is, here I have taken one dp of n table and I and j to loop, then dp of 0 equals to array of 0 and dp of 1 equal to max of array 1 or dp of 0. So either consider the first house or consider the 0th house. Then from I equals to 2 to n minus 1, dp of I equals to max of dp of I minus 1 or array of I plus dp of I minus 2. We have understood the logic before. And finally I'll return dp of n minus 1. What would be the time complexity? It would be big O of n, as a for loop of size n is used. And what would be the auxiliary space? The auxiliary space required here will also be equal to big O of n, because we are taking one dp table of size n, right? So now let's submit this code. So let's submit it. So we have solved this problem successfully. I hope you have understood the solution completely. Thank you.